So what are the statements? 50% roses are flowers, some flowers are buds, all buds are leaves, 100% leaves are plants. And then there are 4 conclusions. Now you got to understand that percentages here are very easy to decipher, right? I mean, 50% roses are flowers. 50% is what? Some. Remember, any percentage between 0 and 100 can be treated as sum. Just remember that 0% is equal to none or no, right? 100% is equal to all, and any other percentage can be taken as sum. That's it. 0, 100 or any other percentage. So 0 is like none, 100% is all, any other percentage, be it 50, 51, 52, 49, 1%, 99%, 99.5%, 0.01%, all those should be considered as sum, right? You know the range of sum, right? Minimum 1, maximum 100, right? In fact, 100% can also be treated as sum, can also be considered as sum. So keeping these percentages and their equivalent meanings in mind, let's draw the basic diagram for the given statement. So 50% roses are flowers means what? Some roses are flowers, some flowers are buds, all buds are leaves. 100% leaves are plants means all leaves are plants. So now these statements have been converted to the regular ones. So some roses are flowers, draw the basic diagram. Some roses are flowers, yeah. Some flowers are buds, some flowers are buds. You know what happens in a basic diagram, right? Minimum encroachment. Try and draw the circles or the sets in such a way that there is minimum overlapping. So some roses are flowers, some flowers are buds, all buds are leaves, all the buds are leaves, and all leaves are plants, all the leaves are plants. So this is the basic diagram. This is the basic diagram for the given set of statements. Some roses are flowers, some flowers are buds, all buds are leaves, all leaves are plants. Now let us verify the conclusions in the basic diagram first. Even in the conclusions you will find that some percentages have been used. So 20% means what? Some. 20% is some. 100% here is all. 0% is none or no. None or no. No roses are buds. So some plants are flowers, some roses are buds, all leaves are roses, no roses are buds. Now let us verify the conclusions in the basic diagram first. So first one, some plants are flowers. Some plants are flowers, true. Some plants are flowers. You find that some plants are flowers here. There is a overlapping between plants and flowers, right? So it satisfies the basic diagram. Some plants are flowers, satisfies the basic diagram. But the question that arises is, will it always satisfy? See, basic diagram is one diagram, but there can be multiple diagrams there. There can be multiple such diagrams. There are other possible ways of drawing the diagrams. So if a conclusion satisfies a basic diagram, if a conclusion is true in the basic diagram, then you are supposed to check possible diagrams as well. Now there can be many types of possible diagrams. Do you really have to draw all the possible diagrams and verify? No, not really. Again, with practice it becomes a lot easier, right? In fact, even without drawing the possible diagrams, you will be able to verify the conclusions easily. Like in this case, when it says some plants are flowers, I am 100% sure that some plants are flowers will always be true. Not only in the basic diagram, but any possible diagram that you draw, some plants or flowers will always be true. Why is it so? Logically, if you observe, we know that some flowers are buds. There are always some buds which are flowers, and all the buds are leaves, and all the leaves are plants. See, you can take it like a technique, right? When all leaves are plants, wherever we have leaves, you can replace with plants. Whenever you have all A's are B's, it's like a technique. You can remember this. All A's are B's. All A's are B's means what? Wherever you have A, you can replace that with B. Remember, B is not equal to A, but A is equal to B. Wherever you have A, it can be replaced with B. Wherever there is B, that cannot be replaced with A. All A's are B's need not necessarily mean that all B's are A's. Yeah. So when he says all leaves are plants, wherever we have leaves, we can replace that with plants. Wherever we have plants, that cannot be replaced with leaves, but leaves can be replaced with plants. So all buds are leaves can be taken as all buds are plants. Again, if you observe, all buds are plants. All buds are plants. Like all A's are B. So wherever we have buds, we can replace with plants. So we can replace this also with plants. So some flowers are plants. If some flowers are plants, the definite conclusion is some plants are flowers. So logically, even without the diagram, you can verify that some plants are flowers is always true. Right? The technique is, if all A's are B's, then you can replace A's with B's. You cannot replace B's with A's, but A's can be replaced with B's. So we replace leaves with plants, then we replace buds with plants. So finally, statement itself says that some flowers are plants. Some flowers are plants. And for some A's are B's, the definite conclusion is some B's are A's. For some A's are B's, the definite conclusion is some B's are A's. So some flowers are plants would definitely mean that some plants are flowers. So conclusion number 1 is definitely true. Conclusion number 1 is definitely true, right? It is true in the basic diagram. It would be true in the possible diagrams as well. So like you have seen here, we did not draw the possible diagrams. Without drawing those diagrams also, we can confirm. Yeah. And you don't have to do so much of analysis during your exam. I mean, if you have practiced some 40-50 questions, you would know how to do it directly. Okay. So 1 is definitely correct. Now you can eliminate some options here. Like for example, I can eliminate option 4. Option 4 says either 2 or 4 follows. 1 definitely follows. That's not given here. Yeah. Chalo, anyway, only one option can be eliminated. So let's move to the second conclusion now. Second conclusion says some roses are buds. Some roses are buds. Some roses are buds. Now if you look at the basic diagram, roses and buds are two disjoint sets. Right? We have got roses here and buds here. Do they overlap? No. No rose is a bud. There is no overlapping between rose and bud at all. There is no overlapping between rose and bud at all. So some roses are buds is false. Remember, a conclusion that does not follow the basic diagram, a conclusion that does not satisfy the basic diagram is definitely wrong. Right? A conclusion that does not satisfy the basic diagram is definitely wrong. So some roses are buds did not satisfy the basic diagram. Hence, it can be directly taken as wrong. Yeah. Now, so some roses are buds is wrong. Now, all leaves are roses. All leaves are roses. By the way, because second conclusion is wrong, you can eliminate option 2 here. Option 2 can be eliminated. Yeah. Because option 2 says second follows, whereas we know that second does not follow. Now, third one, all leaves are roses. All leaves are roses. All leaves are roses. Verify this. All leaves are roses? No. In the basic diagram itself, it fails. Leaves and roses do not overlap at all. Leaves and roses do not overlap at all. So how can you say all leaves are roses? Not even a single leaf is rose. So third one also is false. Fourth conclusion, no roses are buds. No roses are buds. Yeah. If you consider the fourth conclusion now, no roses are buds is true. Roses here and buds are here. No rose is bud. Rose and bud do not overlap at all. Roses and buds are two disjoint sets. So can we say no roses are buds? Yes. It satisfies the basic diagram. But what is the classical law? If a conclusion satisfies the basic diagram, then it should be verified in the other diagrams as well. Now let me show you a possible way of drawing this. Let me show you a possible way of drawing the diagram. Right? I'll directly draw roses in a way that you will find that some change happens here. See, what was given the statement, one of the statements said that some roses are flowers and some flowers are buds. Look at the original statement. Some roses are flowers and some flowers are buds. Some flowers are buds. Okay. So we have drawn in this way. Some roses are flowers and some flowers are buds. But there is another way of drawing this. What does it say? Some roses are flowers. Roses and flowers. And some flowers are buds. Can you not draw some flowers are buds in this way? Yes. Now the point to be observed is the moment you consider this possible diagram, no roses are buds becomes wrong. Because some roses are buds. You see, roses and buds overlap. In this possible, are we going against the statements? No, we have not gone against any statement. Some roses are flowers, some flowers are buds. Some roses are flowers, some flowers are buds. We have not got against any of the statements. But what happens? The fourth conclusion becomes wrong. Because fourth conclusion said no roses are buds. No roses are buds is true in the basic diagram, but fails in the possible diagram. Having said that, if you go back and check conclusion number 2, which said some roses are buds, becomes true here. Some roses are buds was false in the basic diagram, but it is true in the possible diagram. So what do you observe? Some roses are buds is true here. In the red diagram, it is true. But no roses are buds is false in the red diagram. It is true in the blue diagram. I mean, I'm using red and blue just to avoid basic and possible words there. But yeah, that's the idea. So if you observe, conclusion 2 and conclusion 4 actually make a complementary pair. 2 and 4 make a complementary pair. Some A's are B's and no A is B is a complementary pair. Some A's are B's and no A is B is a complementary pair. And it actually satisfies here. You see, in one diagram, 2 is true, but in the same diagram, 4 is false. In the other diagram, 2 is false, but 4 is true. So either of these are always correct. Hence, your answer should be 1 definitely follows and either 2 or 4 follows. So 1 and either 2 or 4 follow. Hence, the answer is option 3. The final answer to this question is option 3. Yeah, final answer to this question is option 3. 1 follows and either 2 or 4 follow. 3 is definitely wrong. 3 is definitely wrong. Remember, 2 and 4 make a complementary pair. Some A's are B's and no A is B is a complementary pair. And whenever there is a complementary pair, you have to be a little careful when you are verifying the conclusions. So 1 is definitely true, and between 2 and 4, either one will be true. So option 3 is the final answer.